Okay, let's get this going, seeing what we're talking about here. So 4.1 is looking at introduction for reactions. It's basic that you have the idea of chemical reactions. It's not much to say there. So it kind of jumps in for more 4.4 physical and chemical changes. So physical changes. Here's where it really boils down to. Intermolecular forces, you're not having new chemicals form. You often will have new phases of matter, so solids to liquids, liquids to gases, aqueous included. No bonds are broken, except sometimes dissolving with ionic solids can be talked about that way. Now, you do have changes in properties. These could be conduction of electricity. They could be boiling points, melting points, all these different kinds of things. Physical means and can often be reversed. Okay, even something becoming aqueous can be reversed by getting rid of the water by adding energy to boil off that water. So the main things you want to see is changes of matter, properties lacking chemical change evidence. Chemical changes. You get new things, often new states of matter, but not always. Bonds are broken. Dissolving ionic solids does fit here too, so you can argue it one way or the other. And sometimes on the AP exam, I've seen it one way or the other. Usually depends upon what unit. Definite change in properties. Chemical means are needed to reverse. So you needed to add energy, react with something else, and so on. Good evidence, color change, gas produced, heat and light released. A precipitate form is one they really love to see. So let's just see a couple in example so you can just see what they're like. So boiling water, ooh, very exciting. However, evidence, and these are where things come up and makes it more challenging for AP. The idea of the properties have changed. Okay, gas. As a gas, it has a different specific heat, density, volume, and everything else. State of matter changed. That's another source of evidence. No bonds broken. How can you show evidence to that? You can see in the picture that the atoms are still bonded to the same other atoms. And you have to justify it. Okay? You have to justify how that occurred. So that's another key aspect when we think of these physical and chemical changes. Here's another example, chemical change, right? Because they may show you a picture of different things and saying, how do you justify that? Oops. How do you justify that? You have your chemical reaction, how would you justify that? You see from a color change, where you get your rust, state of matter change, solid to solid in this case, but you have a gas for oxygen, bonds being broken, so you could show that in the image, new compounds being formed, you have a new compound when you didn't. Change in properties. I mean, color's one of them. You could, if they gave you more information, something like iron has a different melting point than iron oxide. Not going to reverse without any other means. Justification, read through that. The idea that you're talking about the bonds being broken, new compound being formed. This gives the reason of the color change. So all very critical when you're thinking of how does this occur and being able to justify how it occurs. So something like carbon dioxide going from dry ice to just up in the air. Thank you for our global warming. You have a loss of mass. You don't have any visible substances being made, so you don't have a color change, which generally would point to a physical change. That's not always true. We know with combustion, what comes in and what goes out are both invisible to us. But you don't have any other signs of a chemical change. You got your justification of why this would be occurring. You should understand basic chemicals when you come to your AP test, CO2, water, ammonia, NH3. The things that come up so many times, you really want to just be familiar with how are they? And they are quite simple because you do have a lot of experience with carbon dioxide and water. But the idea is that you also have your particles here. Same things are bonded to the same things. It looks like they've overcome a force in solid form. So you can always go back to either the visual. They usually don't give a visual like a picture, but a molecular structure they often will love to go with. Something like sugar dissolving, often thought of as a chemical change because you get something different. You can see again in the images, these big sugar molecules are just separated by the water now. Again, no chemical changes occur. How would you know? Solid dissolves, it doesn't react, no other color change, no precipitate made. It would taste sugary, so therefore you could say it retains that property. However, I wouldn't know if that would be a good recommendation on the AP test, because you shouldn't be tasting things when it comes to a chemistry classroom. But there's no other signs of a chemical change. Again, listing those off rather than just saying no signs of a chemical change really isn't going to help to show your reader that you understand things. So you really want to show the different types of things that come to a chemical change, and then, hey, we didn't have any of those. And then again, describing why that would still dissolve, even though it's a covalent solid. One that's colorless in, colorless out. You don't notice the propane and the oxygen, what they look like. Carbon dioxide and water, no difference. So you have no visible evidence, but you have a lot of heat released, usually evidence of bond breaking. Now you do have heat being released when things dissolve as well, but it's far smaller, except for a few examples. You'll see those later in the year. Maybe some water vapor condensing on something, that's a kind of a stretch. When you have justification, you should be familiar with hydrocarbons burning in oxygen. I mean, we've already done that with combustion of calculations. We'll talk about those with reactions. It's very common to have combustion as a very similar common occurrence in chemistry. With enough activation energy, it sustains. Looking at the picture, you go from something very different, the propane, to the carbon dioxide and water. Albeit they don't show you the oxygen here as well, but of course you can see that things have really rearranged, another evidence of chemical changes. Now, again, where is this used at? Mixed throughout. This wouldn't be necessarily any part of a section, but it'll often be part of an FRQ. You need to use the justification in order to talk about those. And you'll either be given chemical equations, particles, observations in a verbal sense. So they say like something like a blue gas was released with light. So you may not even get an image with it, just a description. So if you can picture things from verbal senses, that's where your reading of novels comes into play. Connects to labs, so hands-on experiences is what you so use those hands-on experiences to connect what you cannot on the exam, because you don't have that given to you on the exam itself. So try to think back to our labs of where you saw these things, had to justify and talk about it. Those are the skills that we're trying to build. All right. Let me know if you have questions. I'll see you on the flip side.